All right, let's get back right here, team. How's it going? The first skill that you need to have is drawing a molecules. All right, so we have to review a little bit symbol, the octet rule, and how to draw like the molecule, regular stuff in Gen Chem 1. All right, let's take a look at this symbol periodic table. All right, we're gonna start right here. So we'll use Lewis symbol of group 4. If you still remember, we'll go back to Gen Chem 1. So group 4 have 4 valence electrons. So carbon, we're gonna put out 4 electrons like that. That's a valence electron of carbon. Okay, and each one of these electrons we call them an unpaired electron, which is really reactive. Each one of them gonna go find a partner or from covalent bond eventually. So one of them gonna go get one more electron. So overall, carbon gonna have 8 electrons at the end, become octet. Okay, all right. So that's group 4. Now group 3. Oh, we call this Lewis symbol. All right, we're going to go a little bit further. So group 3, so nitrogen and phosphorus. All right, let's start with the nitrogen. All right, so nitrogen, group 5, how many valence electron? 5 valence electron, right? And nitrogen going to put those 5 valence electron as this. One lone pair, all right, and 3 unpaired electrons right there. Okay, so what's going on in here? So the lone pair is less reactive than the unpaired electron. It won't really it's not reactive, so it won't go form covalent bond as quickly as the unpaired electrons. So eventually, once the nitrogen form bond, nitrogen gonna go form 3 more bonds, right? So right now we have 5, 6, 7, and 8 is gonna be the octet at the end. Okay, all right, we're gonna go to group 6. So you can guess now. So group 6, 6 valence electrons. So oxygen gonna put out 2 unpaired and 2 lone pairs. All right, and group 7, right? So 7 valence electrons. For example, fluorine. So 7 valence electrons. Fluorine gonna put out 3 lone pair, 1, 2, and 3, and 1 unpair, right there. All right, and group 8. Right, group 8. If you still remember, group 8 is an inert gas, doesn't form any covalent bond. Okay, so group 8 is gonna. I'm not gonna form any bond. So no unpair at all. No unpair, just lone pair. 4 lone pairs right there. These are Lewis symbols of each group. Okay, last one we have group 1 right there. Okay, let's take hydrogen. Okay, hydrogen. This kind of a little bit exception because hydrogen have only 1 electron, 1 unpair. That's it. That's all hydrogen can do. So hydrogen gonna go form only 1 bond. All right. All right. Take a look right here. So now. You should be able to write Lewis symbol now. Now the bonding capacity, how many bonds they can form? Well, think about it. Carbon have 4 bonds. That's a valence electron. To become octet, 4 more electrons. So each unpaired electron will go get 1 more, form 4 bonds. That's why carbon usually form 4 covalent bonds. Okay, you probably have seen carbon in diamond or charcoal. All of them have 4 bonds, right? So 8 electrons total. So by itself, so 1, 2, 3, 4, that's like valence electron, and then 5, 6, 7, 8. Okay, so 8 electrons total. Nitrogen, right? Group 5, 3 more to become octet, right? 3 more to become octet. So each unpair, not the lone pair, each unpair will go from covalent bond. So 5, 6, 7, and 8. So nitrogen eventually gonna have 8 electrons by forming 3 more bonds. Okay, so nitrogen usually form 3 bonds. We call trivalent. So nitrogen is like, let's say nitrogen gas, or triple bond right there. Ammonia, so 1, 2, and 3 bonds. Right. So we have NO3, so 1, 2, and 3 bonds there. All right. Oxygen group 6, so 6 valence electrons. So 2 more to become octet. 2 more. So which electron will form bond? Well, you can see the red one, the unpaired one. Each one of them gonna go get 1 more electron. So eventually, normally oxygen forms 2 bonds. It's already octet. Okay, like oxygen gas, or 2 bonds there, double bond, or in water, so 2 bonds. And fluorine and hydrogen, this guy usually form 1 bond. Okay, we call monovalent. All right, so you're gonna see like in Teflon, each fluorine from 1 bond with the carbon. Okay, hydrogen gas. Just like that, so 1 bond right there. That's hydrogen gas. All right, let's go to the practice right here. So just symbol there. How many valence electron? What's the bonding capacity? And can you write Lewis symbol? Okay, so bromine, 7 valence electron, right? Group 7, 7 valence electron. Need 1 more to become octet. So bromine will form only 1 bond. All right. And to form this one bond, bromine will put out only one unpair and put the rest as a lone pair. Look like that. So 7 total, right? So 1, 2, 3, 4, 5, 6, 7. Want to form only one bond, so 1 unpaired. Okay. The rest are lone pairs. Now, iodine, what group is that? Well, go back to the periodic table. Iodine also group 7. So 7 valence electron. How many bonds does it need to become octet? Just one more. I need one more electron. All right. So which means that iodine is going to have 1 unpaired electrons, and the rest going to be lone pair. All right. So 7, 1 unpaired, and the rest are lone pair. So 1 unpaired, the rest are lone pair. 6 of them. All right. Now, silicon. If you look at the periodic table, so silicon is right below carbon. So group 4, 4 valence electron. To become octet, 4 more. All right. Which means that silicon will have to put out 4 unpaired. All right. 4 unpaired. And silicon have only 4 valence electron. Well, just like all they are unpaired. Single electron right there. All right, next one, sulfur in group 6, like in oxygen, right below oxygen. Okay, so group 6, 6 valence electron. How many more to become octet? Think. So 2 more become octet. So bonding capacity is 2, which means that sulfur will put out 2 unpaired, and the rest are the lone pair. Okay, so 2 unpaired, so right there, and we have 6 total. So the other 4 going to be lone pair and lone pair. All right. Potassium. Potassium is in group 1. All right, so group 1, 1 valence electron. Well, 1 bonding capacity. You'll be like, hey, hold on, what's going on here? So don't we need like 7 more? Well, not really. If you still remember, potassium have 1 valence electron, but inside of that valence electron, it's already octet. If you look at the electron configuration, we're not going to go over it today. Okay, so loses electron, become potassium ion, and the insides are already octet. Okay, and that's why potassium will put out 1 electron there, ready to lose that, and lose that become potassium ion. That's ionic bond, not really a covalent bond. All right, but well, I just put 1 bonding capacity there, which is one ionic bond. Argon. So argon is group 8 and inert gas. If you still remember, inert gas doesn't do any reaction. Okay, so 8 valence electron doesn't need any more bond. It's already octet, so 0 bonding capacity, which means that argon doesn't have unpaired electrons. No unpaired electrons, so 8 of them are paired up. 1, 2, 3, 4, 5, 6, 7, 8. Look like that. Okay. All right, let's go to the next video.